Right, for our last exponent law, we're going to talk about the zero exponent. So I'm going to do a couple of different things here to kind of show you how the zero exponent works. The first thing I'm going to do is I'm going to look at a nice little pattern, because we mathematicians, we really love patterns. So if I had 5 to an exponent of 3, we know that that would be 125, right? 5 times 5 times 5. And if I had 5 exponent 2, that would be then 25, right? And that's 5 times 5. I'm only taking two 5s multiplying together. Then if I had 5 with an exponent of 1, well, that's just the 1 5 all by itself, right? So normally what we think of is we think about as we increase our exponent by 1, right? So our exponent goes up by 1, we multiplied by another 5, right? And then as my exponent went up by 1, I was multiplying by 2 5s, and now there's a third 5, so I multiply by 5 again. So as I move up this list, exponent goes up by 1, I times my answer by 5. As the exponent goes up by 1, I times my answer by 5. Okay? So what I'm going to do now is I'm going to actually go down my list and see what happens. So I'm going to, instead of thinking of making my exponent go up by 1, now my exponent decreases by 1. So my exponent goes down by 1. And I go from 5 exponent 3 to 5 exponent 2. And what happens is I remove one of my 5s. Well, the only way I can remove a 5 is I have to divide by 5, right? So if I had 5 times 5 times 5, if I divide by a 5, those ones would cancel, and now I have two 5s left over. And if I decrease my exponent by 1 again, then I'm going to divide by 5. This is my pattern, right? And if I do that one more time, if I decrease my exponent by 1, now my exponent becomes a 0. Well, my pattern tells me, since I decreased my exponent by 1, I must divide by 5. And 5 divided by 5 is 1. Okay? I get that anything with an exponent of 0 is 1. Now I'll do it again. Okay, I'll do it again. I'll use a different number because it's good to do these things with different numbers. I'll even make it a little bit more difficult. I'll throw in a negative for my base. Okay, all right, so negative 2 to an exponent of 4 would be positive 16, right? Because that's negative 2 times negative 2 times negative 2 times negative 2. So there's 4 negatives, so it's a positive answer. 2 times 2 times 2 times 2 is 16. Well, I'll decrease my exponent by 1. So we'll say negative 2 now to an exponent of 3. So that's going to give me negative 8, right? Because I now have 3 negatives, so I get a negative answer. And 2 times 2 times 2 is 8. So I have negative 8. And again, I decreased my exponent by 1. And what I did here was I divided by, and in this case, I divided by a negative 2. 16 divided by negative 2 gives me negative 8. Well, let's go down our list again. So I'll decrease by 1 more in my exponent, and I'll divide by negative 2 again to get positive 4. And then I'll decrease my exponent by 1 to get an exponent of 1, and I'll divide by negative 2 to get negative 2. And then I'll decrease my exponent by 1, and I'm at an exponent now of 0. And I'm going to divide negative 2 by negative 2, and that gives me positive 1. So again, I get this exponent of positive 1, and it works even if my base is negative, and it becomes positive 1 because 0 is an even exponent. Okay, so I'm going to show another way of showing how the zero exponent works. So let's say I had something like 3 exponent 4 divided by 3 exponent 4. Okay, well, I know 3 exponent 4 is 81. And then 81, and 81 divided by 81 is 1, right? But using our quotient law, if I had 3 exponent 4 over 3 exponent 4, so the same expression I started with before, my quotient law says since the bases are the same, I can subtract those two exponents. And when I subtract those two exponents, I get 3 with an exponent of 0. Well, if I was to write that out in a line, right? So here's 3 exponent 4 over 3 exponent 4. We said that's 81 over 81, and we said that's 1. I also said another way I could write it is 3 exponent 4 minus 4, and that's 3 exponent 0. And the way equal signs works is everything here is equal to itself, to its neighbor. And so I can move from 3 exponent 0 all the way over to 1. Okay? So our 0 exponent is, anytime we have a 0 exponent, we get 1. All right? And that's our, oops, I don't know what happened there. And that is our last exponent law that we cover in grade 9. There are more that deal with negative exponents as well as fractional exponents, but this is the last one that we're going to deal with this year. Okay, so it's any base to an exponent of 0 is 1. And that is it. Very simple. Okay, so any base raised to an exponent of 0 is 1. Now there is one caveat. The only base that doesn't work is 0. Okay, so any base that isn't 0 raised to an exponent of 1 is, any base raised to an exponent of 0 is 1. Okay, the only one that doesn't work is 0. The reason it doesn't work, I'll just show you very quickly. Remember those patterns, how mathematicians, we love patterns. If I have 0 exponent 3, that would be 3 zeros multiplying together, so that would give me 0, right? And then 2 zeros multiplying together gives me 0. And then 1 0 gives me 0. And then 0 zeros, if I had 1, my pattern breaks. And now that doesn't make any sense, right? If I also tried to do this, like we did before, well, I'm not allowed to do that because now I have a 0 in the denominator and I'm dividing by 0. That doesn't work. If you try to type in 0 exponent 0 on your calculator, it's going to tell you error, or doesn't work, or something improper, or set on fire. So again, don't put 0 exponent 0. Spontaneous calculator fires could occur. That exponent law tells you any base to an exponent of 0 is 1, except for 0 itself. All right, there's our 6th and final exponent law.